Since the time of the ancient Greeks, people have wondered about the answer to the question, what is matter made of? For a long time, humans have believed that matter is composed of atoms, and in the previous 3 centuries, we have collected much indirect evidence to support this belief. Very recently, something exciting has happened. For the first time, we can see individual atoms. Of course, we cannot see atoms with the naked eye, but must use a special microscope called a scanning tunneling microscope, STM. Although we will not consider the details of its operation here, the STM uses an electron current from a tiny needle to probe the surface of a substance. The STM pictures of several substances are shown here. Notice how the atoms are connected to one another by bridges, which, as we will see, represent the electrons that interconnect atoms. So at this point, we are fairly sure that matter consists of individual atoms. The nature of these atoms is quite complex, and the components of atoms don't behave much like the objects we see in the world of our experience. We call this world the macroscopic world, the world of cars, tables, baseballs, rocks, oceans, and so forth. One of the main jobs of a scientist is to delve into the macroscopic world and discover its parts. For example, when you view a beach from a distance, it looks like a continuous solid substance. As you get closer, you see that the beach is really made up of individual grains of sand. As we examine these grains of sand, we find they are composed of silicon and oxygen atoms connected to each other to form intricate shapes. One of the main challenges of chemistry is to understand the connection between the macroscopic world that we experience and the microscopic world of atoms and molecules. To truly understand chemistry, you must learn to think on the atomic level. We will spend much time in these videos helping you learn to do that. One of the amazing things about our universe is that the tremendous variety of substances we find there results from only about 100 different kinds of atoms. You can think of these approximately 100 atoms as the letters in an alphabet out of which all the words in the universe are made. It is the way the atoms are organized in a given substance that determines the properties of that substance. For example, water, one of the most common and important substances on Earth, is composed of 2 types of atoms, hydrogen and oxygen. There are 2 hydrogen atoms and 1 oxygen atom bound together to form the water molecule. When an electric current passes through it, water is decomposed to hydrogen and oxygen. These chemical elements themselves exist naturally as diatomic 2-atom molecules. An oxygen molecule is written O2 and a hydrogen molecule is written H2. We can represent the decomposition of water to its component elements, hydrogen and oxygen, as follows. You have 2 water molecules written 2H2O. You add an electric current, and you get 1 oxygen molecule written O2 and 2 hydrogen molecules written 2H2. Notice that it takes 2 molecules of water to furnish the right number of oxygen and hydrogen atoms to allow for the formation of the 2-atom molecules. This reaction explains why the battery in your car can explode if you jump-start it improperly. When you hook up the jumper cables, current flows through the dead battery, which contains water and other things, and causes hydrogen and oxygen to form by decomposition of some of the water. A spark can cause this accumulated hydrogen and oxygen to explode, forming water again. So you have O2 and 2H2, you add a spark, and you get 2H2O. This example illustrates 2 of the fundamental concepts of chemistry. 1, that matter is composed of various types of atoms, and 2, that one substance changes to another by reorganizing the way the atoms are attached to each other. These are core ideas of chemistry, and we will have much more to say about them.